Okay, if you had chose to write this problem down, great. If not, it's just one of the things that we'll try to accomplish in instructing you how to, accomplish the combined gas law. Okay, that's what CGL is standing for. So, how many of you can write straight across with no lines? Look at that. No lines, but pretty straight across. But at least tell me if you're writing, it goes up. You know what that means?
You're left-handed.
Probably, but no.
Because right-handed people go down.
It's believed that if you write upwards, you're an optimistic person. If you write downwards, you're a pessimistic person.
I'm optimistic. You want to switch?
Sure.
No, left-handed people are just told they're going to die at a very young age. You left-handed? Yeah, me too, bro.
There was a mistake with this. Okay. Now, whether you had that wrote down, that's not such a big deal. When you do the setup, that's where the information is actually more important. Okay? So, when you see something like this, can humans go up to Mount Everest?
Yes.
Yes, you can. Is there a problem with that?
Very little oxygen.
Do not stay there very long.
Yeah.
Okay? And I would be led to believe that some people might have the mentality, okay, we're technically on top of the world, the highest peak. They want to spend a little bit of time up there, but that can be catastrophic. Why might that be? Not just because of little oxygen. It's going to be cold. It can probably get dark quicker than what you might think. And I would be led to believe there's probably lots of cracks and crevices that you could probably fall down into. I don't know what the right term for that is. A place where you can't probably crawl out of, and that's probably happened. But some people might have this on their, if you want to call it a bucket list, or something they want to try to accomplish. I'm not one of them guys. Maybe you're one of them guys or one of them gals. That is maybe true, but I have no aspirations. It's probably not cheap either, okay? But if a human is going to try to do this, which some have, can they go up there without any assistance as far as breathing, do you think? I think they probably can, but there again, don't stay there very long. And just think climbing to that type of an altitude is probably pretty taxing on our body. But just think if you are a bird going through a migration pattern, which our zoology book talks about different types of geese that routinely fly over this peak, and they don't have any restrictions on them. They could, not that they would land, but that type of movement across a mountain that high, that's pretty incredible to be able to accomplish that. So you probably would have guessed that the class Aves, okay, if we were to classify humans, our closest classification is what? Because we've got hair. Yeah. If you want to, I always say humans and mammals, we're pretty close related to one another, but who's got a more efficient respiratory system, mammals or aves? Yeah, the avian respiratory system is by far way more advanced than that of humans. Okay, so when you go through this, you've read the problem. Does anyone have the formula?
No, I'm trying to figure it out.
Okay, your formula would be as follows, okay? Okay, so as you would guess, you're combining temperature and pressure to calculate a specific volume. And that's what you're trying to accomplish here. And what can happen is where you're putting all these variables is where the possible hindrance could be, if you want to call it that, that could possibly take place. I guess we probably could leave the door open because it gets pretty quiet pretty soon, and then is it a mini Zamboni? Is that what you call that, or just a sweeper? Yeah, I don't know. We'll floor cleaner. Okay. So if an observer begins, there's your clue, okay, at base camp with a temperature of 40 degrees centigrade and a volume of 615 milliliters and a pressure of 0.88 atmospheres. What is the pressure at higher altitudes where you have this temperature and then this volume? So what are your initial conditions up at altitude or at the base camp? At the base camp, because it's saying you're beginning here, and then what is the pressure at a higher altitude where you're changing your conditions? So there are 6 variables here, V1, P1, and T1. And we will test your algebraic skills here. Okay? Is there any conversions that we need to do?
Everything stayed the same, so no.
Just one conversion. Yep, we need to change 40 degrees centigrade to kelvins. Okay? So our first temperature, 40 degrees centigrade, is 313? 27? Yeah, that would be 40. Okay. Even a blind squirrel finds an acorn every now and then. You ever heard that before?
Oh, yeah.
That means sometimes a person gets lucky. They just guess. 313 sounds right. Okay. Okay, what is our initial pressure? 0.88, okay, and that is atmospheres, okay. Do we have an initial volume? Of course. 615 milliliters. So then, what is the pressure at higher altitude? So what is our new pressure?
New pressure is what you're finding.
What we don't know. That's right. Okay, so what is our second temperature?
255 Kelvin.
Okay, so one way you can look at that is you can just subtract 18 from 273, and that will give you your answer. So in that case, you said what, 255? Okay, our second volume is right here, 430 milliliters. So once you get this in your setup, you just put your variables in where they belong in the formula, and there's your algebraic skills. Just do what the formula tells you to do. Okay. So here's our equal sign. What's on top of this fraction? These two, right? 615 times 0.88. Okay, and then what is on the bottom? 313. And the right side, we got our new volume, which was 430. And then on the bottom is our new temperature, 255. So what does your tell you to do? Is everyone caught up and have this wrote down? Because we don't want to just keep on moving and just presume that we've got this and we can proceed. So do we have it up to this point? What's all the way back to physical science? We got two fractions. I would prefer get rid of your fractions. And you said that already. And how would you go about doing that? Okay, so 313 times 430. Okay, 134,590. But a number times a variable gives you that number and your variable. So what's on the right-hand side of our equation now? 615 times. See, is anyone saying 0.88? No. No one's either says 0.88 or 0.88. We had this discussion yesterday, didn't we? Yeah. Okay. Yeah. So 0.88 then times 255. Then that gives us 138. That's not what you got? Oh, okay. Because I heard different numbers. Oh, okay. Now you're home free. You just need to get pressure 2 by itself. Each side by what? Okay, dividing each side by this will free up that variable.
No, but we didn't have a third decimal spot. Can't use that logic, Ruby.
Okay, you can't necessarily use that same type of logic, okay, with Boyle's and Charles's law. Here we see the pressure has actually gone up, which I think is probably not a very accurate problem. You're going to get higher in altitude, the pressure is definitely going to be less.
So I'm guessing here.
Did we make a mistake here?
No, we did that right. So
Okay.
it just means once you go up, either your temperature either has to, it'll have to go down, but your volume will
And it could be such an aspect that maybe that temperature was too high, or maybe that wasn't low enough. That could be. There is no problem out of a book. I just started writing, said, oh, this sounds like, well, let's try this.
the right answer, but it doesn't.
Yeah. It's where the numbers would lead you. But that's what we're looking for. All right. Rut row, are we good so far?
88 degrees.
Okay. Second row. Third row. All right. That's really all I've got. I don't have anything to hand out.
We have a question about yesterday.
Oh, okay.
Yeah.
So there's a question on number 2 on Charles's gas law. Standard temperature is 273 degrees Kelvin, not negative 273. So hopefully that will clear things up, because we'll talk about that more with the ideal gas constant when we get to that next week. All right. That's all I have. We'll catch up to you next time.
So wait,